Hello YouTube. This is a video like the title says, aftermath of the sliding flip front end. We have a couple of problems. One is this is the relay for my cooling system that used to go right there. It's a relay for the water pump, the fan, and both of the fans. And it can't go there anymore, so we got to do something about that. This radiator, it's the first time we've had the radiator in the car with the hood on it, and it just hits the hood. So we're going to have to do something about that. And the engine ground is no longer connected to the chassis because of the rail. So there's 3 projects that we've got to complete. This is a view up inside the fender well. It's the best shot I can give you. If I slide the hood forward and slide the hood back, you can see where it just touches the radiator. I mean, it's not by much, but it is touching the radiator. This is the inside of the hood with the hood flipped up and the brace that's hitting the radiator. And what I could do is just lop off an inch or 2 inches off of that and would fit just fine. But I want to retain the strength, and there is another option. Option number 2. This radiator, if you look at it, is actually tilted forward a little bit. If I was to tilt it back, then I would have the clearance I need without cutting a hood. And the other reason I would tilt it back is the motor itself is at 8 degrees, and I know that because we did the powertrain angles, and the chassis is actually angled up because this is a gasser. So if I put this back a little bit, it'll line the radiator more with the chassis than if I was to leave it straight up and down. Now, I don't know how to cut a piece of metal in a wedge. I haven't figured that out yet, but I will. And what I'm going to do is I'm going to take this piece of metal and put it underneath the leading edge of the radiator mount to lean it back and see what we get. Let's loosen these radiator support bolts up enough to get this piece of metal under the front edge. Okay, so it's slanted back. Let's see if we can get the piece of metal underneath the edge. I can't see what I'm doing. It feels like it's too thick. If I'm in the right spot. I think I'm in the right spot. And this piece is too thick. It really doesn't need that much. All right, let's find another piece. What I found was a factory shim that belongs underneath the radiator. But I only put it in halfway. And I think we got the angle just about right. If you look at the angle of the radiator and the angle of the motor, the radiator is not quite as tilted as far back as what the motor is, but I want to keep the clearance between the water pump and the fan. So I think I'm going to leave it right there, and I'm going to have to figure out how to make a shim that's that thin in the front and tapers to nothing and put it under that radiator support. I figured out how to make the wedge, and it's actually pretty simple. I don't know why I didn't think about it. Well, what I did is I took one of the original shims and I just took the hand grinder and ground down one side of it so it's real thin on one side and thick on the other side, and that'll give me the wedge. Now, what may happen is right now what we have in the radiator is a wedge this thick right up against the bolts, and now this is going to be even with the rest of the shims, so it may not tilt back quite as much, but we'll see if it's acceptable. I got our bolts loose, and we'll get this shim out. What I have here is an isolator and our wedge shim. And in order to put it in, I have to pick the radiator up and then slide them into the bolts. So there's the radiator up, and there's the shim and the isolator in place. And now we're going to have to tighten this up. With the radiator tilted back, we can see that we now have lots of clearance at the top. That's the hood all the way in the back position. We have the block up against the shock mount. The hood can't go back any further, and we now have clearance for the radiator. There's a wedge underneath it. I think this problem was solved. Well, that one was pretty simple, straightforward. I'm pretty happy with the solution. This next one's not that easy. This is the relay panel that I made for the fans and the water pump. And it used to go right there. And the leads for the fans and the water pump would then continue on. Can't do that anymore. There's no real place I can put this with the wire that I got. So I have no choice to rewire. I have a convenient frame body disconnect right here. So I can disconnect all of this from the body and rewire it. And I think that's the way to go. I think what we'll do is take these circuit breakers, move them back, and put the relays right there. By disconnecting this frame to body connector, we can lift the whole wiring harness out of the car. Let's get rid of some of these holes here and give ourselves a blank canvas to work with. Let's grind these welds off. And now we have a blank canvas to work with. What we have here is the wiring harness that we just removed from the car with the black wire loom removed. At this end, we start with the connector that goes between the frame and the body. The next thing we come to are the two wires for the trans brake, the wire for the starter solenoid, the two power feeds to the car. This one goes to a 30 amp circuit breaker, and this one goes to a 50 amp circuit breaker. This circuit breaker feeds the water pump and the two fans. This circuit breaker feeds everything else. This wire is for future lighting on the front of the car. I don't know what I'm going to do with that yet. These three relays control water pump, fan number 1, fan number 2. This is the connector for the two fans, and this is the temperature sensor for the auxiliary fan. And we have to put all of that in the new harness. Now, some of this we can save. For example, this power lead is actually going to be shorter when we put the circuit breakers closer to the firewall, so we can save part of that, and so forth. First thing we're going to do is take the pieces apart. We'll remove this and we'll clip wires here so that we have something to solder to. The nice thing about these connectors, and I've forgotten the name of them, and I actually did a video on them. I'll put the name up above. But the nice thing about them is they're rebuildable. I can take them apart and reconnect them. You can't save the pins, but you can save the connectors. And what we're going to do here is clip all the wire ties to let the wires go loose. Now, for example, we can save this wire. This wire doesn't change at all. This is the wire for the headlight. So we just lay it off to the side. And the distance between this connector and the trans brake hasn't changed, or won't change. So we can put that aside. And the solenoid wire, the distance shouldn't change. So we can put that wire aside. Those things we don't have to do. The next thing we can do is save the power wire. we just have to shorten it. So I'll have to put a new end on it. And I'll show you how to do that. That's not a big thing. We'll separate the relay from the power lead so that we can mount the relay in its new location on the frame. This lead is useless to us because it's going to be much longer, so that's destined for the garbage can. This lead is going to be too long, so we can shorten it by cutting the end off and putting a new lug on it. And we have our two relays. Now's the time we have to start cutting. These two wires, the blue one is the water pump, the purple one is for the fans. And these are demand wires. They go to the relays and tell the relay to send power to the fan. They're coming from the car. They're going to be shorter. We can cut them here and have plenty of wire left over. And that separates the relay from the rest of our wiring harness. Now these leads, this sensor lead is going to have to be longer, and we can clip that right at the base of this heat shrink so we don't have a connector in the line. We can disconnect the grounds from our relay plate. This wire to the fan from the relay is long enough where we can make another connection to it, so we'll cut it out. So we only have one connection. This wire from the relay is also long enough, so we'll cut it off. And the same way with this wire. Those are all the hot leads for the water pump and the fans, and it should be disconnected now. So that harness is separate. So the relay is separate. Now we can go to the car and start planning. We'll plug in the power lead for the chassis, and we'll plug in the master jack. And these wires should be long enough to complete their original mission. This is a solenoid wire. It still reaches. This is the trans brake wire. It should still reach. We're not changing the length. This power lead is going to have to be shortened. These two sensor leads, which are the water pump and the fans, have to be shortened. And this one just runs to the front. This was originally here, and I put it on a plate because the frame was so narrow that I wouldn't have been able to put the relays on it and have the wires come out the bottom. Now we're going to put it here, and I believe we can take the relays off the plate and mount them directly to the frame. It'll have a better appearance. And the other thing it does is it helps with access to the starter. If this is sticking up above the frame, then I have less access to the starter. So I think the relays get mounted directly to the frame. And then I think our two waterproof circuit breakers go right there. So I'm going to punch a bunch of holes and mount a bunch of stuff. We'll punch our layout marks for drilling. We'll drill 1/8-inch pilot holes. Now that we have our components mounted, I'm going to start routing the wires that haven't changed and add to it as we go. We've run some of the preliminary wires. Trans brake is hooked up, solenoid is hooked up, but the wire's a little long. I'm going to have to shorten that. This is the lead for the fans and water pump, and we can cut that off to length. We're going to want to put an eyelet on there, so we'll cut it off right there. And this is the lead for the vehicle, so we can cut this one off right here and put some eyelets on there, and we're making progress on reconnecting this circuitry. This is the solenoid wire that we have to shorten, and this is how I put an eyelet on a small piece of wire. And just strip it, need a little bit more. put the heat shrink on, put the eyelet on, crimp it, put it in my third hand, solder it. Slide the heat shrink down on it, shrink it up, and we shortened our solenoid wire. What I think we need to do now is make up the two power leads that go to the circuit breakers. Connect right here. We need to run from the starter terminal to here. This, when hooked onto the terminal, is a couple inches short for each relay. This connection is not soldered, it's crimped. So let's go do that. Here's our terminal with the two wires in it. And we'll put it in a press and we'll crimp it. And no amount of pulling is going to get that out. We'll put some heat shrink on it. This blue wire is for the water pump and this purple wire is for the fan. These relays come with pigtails that are dead-ended, so we have no choice but to do an inline splice. And this is how I do that. I'm going to take the relay off so that I have some more wire to play with for this inline splice. We'll strip back about an inch of insulation and do the same thing with our demand wire for water pump. We'll slide some heat shrink on, and then we're going to twist these wires together. And solder it. Slide our heat shrink over our connection and screw our relay back into place and tuck the wire up underneath. So now you've seen how I do a lug connection, how I do an eyelet connection, and how I do an inline connection. We have recreated this wiring harness. We've got the circuit breakers, we have the relays, we have the power feed to the circuit breakers, we have the lead from the relays and up to the water pump and the two fans. What's left is to connect up the engine ground, and that's a matter of drilling a hole. I'm going to put it right about there. Here we are drilling a hole for the ground for the engine. We'll take our ground and put a bolt through the lug and put the bolt through the subframe. Put a lock washer and a nut on the back side. Tighten it up. And I think we've accomplished the three things we wanted to do. The last thing is to test them all. Let's see if we did them all right. The first thing we'll do is test the fan. Can you turn the fan on? Okay, turn it off. So the main fan works. The next thing we'll do is check the water pump. Now the water pump you have to listen very carefully for because it is quiet, and she'll turn it on and off so that you can hear it. Alright, so the water pump is working. The last thing we have to do is check the auxiliary fan. Now the auxiliary fan runs on a temperature sensor, and it won't come on until we reach 185 degrees. I'm going to fool it by grounding it, and that way we'll know whether it works or not, but it only works when the main fan is on. Can you turn the main fan on? Okay, turn it on. So the main fan runs and the auxiliary fan runs. And the last thing we have to do is check the engine ground that we did. So let's check that. So I guess that works also. I have actually thought about one more project we can do if you're interested. We only tack welded these brackets together. We need to weld them together, and I would consider it an aftermath of the sliding flip hood, so we'll include this on the video. We'll take the bracket off to weld it up and clean it up. I want to through bolt these. We have to be careful of this nylon ball. It's susceptible to heat. I ruined 3 of them just tacking it onto the tube. So I'm not going to do any more welding around here. I'm just going to weld here and here and here and here. The thing is that when we weld here, we have to make sure that we keep this cool, and we'll do that with air. Weld a little bit, then blow it off to keep it cool. Now we'll carefully grind the weld so as not to get anything hot. With the balls all taped up, we'll paint them with some flat black paint. We'll tighten up the last bolt here, and that's just one more task that's done. Well, I know those weren't the most exciting of tasks, but I can only show you what I'm working on. I think they look a lot better. I do want to get them through bolted. These sheet metal bolts are no good. So if you enjoyed this video, there'll be more.